We know alkanes are saturated hydrocarbons having the general formula CnH2n plus 2. By using this formula, we see that the first three hydrocarbons, that is first three alkanes in this case, are methane. That is the first one having one carbon atom. The molecular formula of methane is CH4 and the condensed or the abbreviated formula is again CH4. For ethane, the molecular formula is C2H6, and when we write the abbreviated or condensed formula, we get CH3 and a single bond between the two carbon atoms, so we get CH3CH3. Similarly, the third alkane, propane, having the molecular formula C3H8, and that is the abbreviated or condensed formula. Now let's look at the type of isomerism which is possible in alkanes. Let's look at butanes. This is the structural formula of butane. If we count the number of carbon atoms, we get 1, 2, 3, 4. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen atoms. So this is the molecular formula of butane. Now, if we move one methyl group and we bring it down. So we move one methyl group, we bring it down, we attach it to the second carbon. So now we get 2-methyl propane. Again, let's count the number of carbon atoms. We get 1, 2, 3, 4. And if we count the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 10 hydrogen atoms. So if we see, both are isomers because they have the same molecular formula but different structural formula. But this is the normal butane. This is the structure of butane as we represent in the normal form. So this is also known as N-butane or normal butane. And for the same molecular formula, when we get a different structure by moving one methyl group, this is known as isobutane. So these are the two isomers of butane. Now let's recall what type of isomers are possible. We know the chain isomers are compounds having the same molecular formula but different arrangement of carbon atoms in the straight or the branch chains, and the position isomers are compounds having the same molecular formula but different position of the functional group in the compounds. Now if we look at the two isomers of butane that we got, so we have the normal butane and isobutane. If we see, there is a difference in the arrangement of carbon atoms in the straight and the branch chains. So these two isomers are the chain isomers. So for butane, we get the two chain isomers. So the type of isomerism which is possible in alkanes is only chain isomerism. Let's look at pentane now. This is the normal structure of pentane. We have C5H12. We get that from the general formula CnH2n plus 2. So when we write it normally, this is also known as normal pentane or N-pentane as we write it. Now, if we move one methyl group, we bring it down. We place it like this, we get 2-methyl butane. Again, if we count, we get 1, 2, 3, 4, 5 carbon atoms. And hydrogens, we get 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we get 12 hydrogen atoms. Now, if we again move one methyl group, we place it like this. So this time, if we count the number of carbon atoms, we have 1, 2, 3, 4, 5. And hydrogen atoms, we have 3, 6, 9, and 12. So in the three cases, you observe that the molecular formula remains the same. That is C5H12. But the first one is a normal pentane. So that is also N-pentane. In the second isomer, we move one methyl group and place it in the second position. So such an isomer in which we move one methyl group, that is known as isopentane. That is the isomer. We use the word iso, the prefix, and since it is an isomer of pentane, so we write isopentane. And when we move two methyl groups, so in the third isomer, we have moved two methyl groups, such an isomer is known as neo. And since it is an isomer of pentane, so this is known as neopentane. So these are the three isomers of pentane. That is the normal pentane, isopentane and neopentane. What do you observe in these three? Again, you observe that there is a difference in the arrangement of the carbon atoms in the straight and the branch chains. So these are chain isomers. Let's look at a question here. What type of isomerism is shown by alkanes? So if we look at the structures, if you look at butane, we saw that there were two isomers possible, the normal butane and the isobutane, which we got by moving one methyl group. Such an isomer which is obtained by the different arrangement of carbon atoms in the straight or the branch chains are known as chain isomers. So the type of isomerism which is possible in alkanes is chain isomerism. Now let's try to find the structure of methane. When we write it on paper, that is on a two-dimensional surface, this is how we represent it as. We have one carbon atom. It is joined to four hydrogen atoms by single covalent bonds. So this is how we represent it on board or on paper, because we have a two-dimensional frame. Now we know that carbon and hydrogen, they have electrons. In physics, you have studied that like charges repel. So in order to have minimum repulsion, the atoms try to be at the maximum distance away from each other. So the actual structure of methane is a three-dimensional structure. As we see here, the carbon is in the center, and these are the four hydrogen atoms that you see. So the four hydrogen atoms are arranged such that the angle between the two hydrogen atoms, any two hydrogen atoms, is 109 degrees. So this is the structure of methane. This structure is also known as a tetrahedral structure. As you see, it represents a pyramid. The carbon is in the center, and the four hydrogen atoms take the vertices as they take in a pyramid. So this structure, which is also known as a tetrahedral structure, is the actual structure of methane. So the structure of methane is a tetrahedral structure.